So, what to do in case of elimination of this? So, that is where we are coming to our topic, heat soaking. So, heat soaking is the process, it's a destructive process by which you reheat the glass in an oven. Here you can see we have put the glass inside and reheat the glass into the oven at 290 to plus or minus 10 degrees Celsius. We accelerate the change of phase of nickel sulfate. We want particularly the glass to change from one phase of nickel sulfate to the next phase of nickel sulfate. If at all the glass has a nickel sulfate which is smaller in quality, we ask it to grow in sizes and it breaks. So, it is a destructive process by which in case the glass has a nickel sulfate, it breaks inside the oven, and the glass which comes out of it will have zero or very minimal nickel sulfate included in the glass, or it will not break. It is in the phase where it is in the compressive area, it will not break in the future. However, there are some researchers, there are n number of journals published on this heat soaking and the nickel sulfate. One gentleman called Mr. Casper has done numerous experiments with this. So, he still says even after heat soaking, there are probability of 1 breakages in 10,000 glasses. 1 breakage for 10,000 glasses is still a probability. So, we have a reference standard for it, EN 14179. So, how does it do it? There are 3 phases in this. One is heating phase, second is a holding phase, and the cooling phase. So, in the graph you can see this 3 phases indicated fully: heating, cooling, and in heating phase our idea is to heat the glass. When it is tempered and cooled and kept it ready, we heat the glass again from the room temperature, means we reheat the glass from room temperature to 280 degrees Celsius. How do we measure the 280 degrees Celsius? It's normally a batch operation. In a batch you put 10 thermocouples at different locations to ensure all part of glass have reached it. So, you can see 2 graphs. One is if you have a batch of 20 glasses, the first glass, all the thermocouples will be aligned, and the range, all thermocouple has to, the last thermocouple also has to reach more than 280 degrees Celsius. Means the temperature measured in the last glass also has to cross 280 degrees Celsius. Until then the heating phase will continue. So, heating phase will continue until the last glass also reaches 280 degrees Celsius. Once it has crossed 280 degrees Celsius, then it goes to the next stage. The key challenge here is to have a oven calibrated to have a specific rate of heating. The specific rate of heating is 3 degrees per minute. So, it has to be heated at 3 degrees per minute max. So, it should be always less than 3 degrees per minute heating. So, the precise control is on the calibration of machines, heaters, and availability of the spacers and other things. We will go in detail how it can be maintained and how a calibration process works about. So, rate of heating should be less than 3 degrees per minute. Now, the second phase is what we are going to discuss here. This is on the holding phase. Here, we have to maintain the temperature at 280 degrees Celsius constantly. All the thermocouples, means all part of glasses should be more than 280 degrees always. There will be small additional heat, incremental heat given to maintain the temperature, and minimum it should be maintained for 2 hours. There are several theories which has been worked out. People have done several experiments to see how much is the hours of holding we have to have. There are articles saying we can have a faster holding rate, means less than 2 hours. There are sometimes it is more than 2 hours, but minimum 2 hours is what we recommend. Normally the 2 hours becomes the standard now. Okay. The precise oven control is much more critical in this area, because if you don't control the temperature precisely, there are possibility of glass temperature shooting more than 320 degrees, which is not acceptable. Any point in time greater than 320 degrees Celsius is not acceptable. So, always it has to be less than 320 degrees Celsius. So, the third phase, now we are talking about the cooling phase, this part of the phase. Here the aim is to cool the temperature to the room temperature again. The rate of cooling has to be in a phase that it does not have a thermal stress to the glass. We cannot have a rate at which we break the glass because of cooling, and we cannot have a rate which is much slower, which is not economically viable. So, normally it is in the same range of heating or just higher than the heating range. So, cooling phase, it ends normally at 70 degrees Celsius. Since the delta T becomes very lower, it is impossible for us to cool further with the additional force. So, after 70 degrees Celsius it is allowed naturally to cool. but the faster rate of cooling is achieved between 280 to 70 degrees Celsius. So, typically if you have to put a cycle into this, the heating will be around 3 hours and holding can be around 2 hours and cooling roughly will be around 2 hours. So, a cycle of heat soak will have 7 hours. So, number of glasses depends on the oven type, number of tonnage of glasses in the oven depends on the oven type and the heating capacity of the oven and the calibrated structure of the oven and our ability to load and unload the oven. So, this is what I am stressing upon. The rate of cooling should be controlled to minimize the risk of glass breakage due to the thermal stress. If you cool at a faster rate, there is a risk for breaking it. So, how does it do it? The heat soak oven normally contains 3 things. One is oven, for which we have the heaters and the thing. The second is the glass support. Third is a separation system. The oven should be calibrated or shall be calibrated. With this determines the amount at which the operation of the heat soak. The total processes depends on the calibration of the heat soak oven. So, this is a typical oven which we use here. Here you can see glasses. So, area where I am marking is where the thermocouple is placed. So, here you can see the oven is made of, usually the ovens are heated by convectional forces. It is not direct radiation, it is more of convectional force and it has to allow an unhindered airflow. So, you can see number of blowers at the top and it has vents at the bottom to go out and keep recirculating hot air, and it is usually a convected heat oven is what normal. In case even there is a breakage, if there is a breakage in the glass, we have to keep the separating systems and support system in such a way that it does not hinder the next glass. The aim in this process is to break the glass having the nickel sulfate. The aim is not to have a glass, error free glass or breakage free glass. Aim is to have a defective glass broken in the oven. So, the key point is again highlighted here. The openings has to be included to ensure that even the broken glass is there. It should not hinder the process of doing it. The second step is the glass support. The glass support here we are talking is about the vertical and the horizontal support. So, you can see the vertical support is and horizontal support is laid such a way that the glass should not be overly having additional stress introduced by it. It's normally 15 degrees of inclination, max 15 degrees of inclination is allowed, and the glass has to be separated in such a way that it is supported uniformly. So, here you can see several separators at the bottom which is uniformly supporting, and the bottom support is always not with a direct metal contact. It has a Teflon which obstruct the contact between the oven and remember, when you are heating the furnace, when you are heating the glass, even the steel structure will get heated. So, it cannot have a direct contact with the glass, which will have an additional stress into at the local point and it can cause a damage to this. So, third part of it is the glass separator. You can see this is the separators which are used. So, the aim is to have 20 mm evenly distributed across. For example, you have to have each glass, the glass has to have a difference of 20 mm and the distance of every 40 mm you need to have a separator. So, these all defined in this standards, the where you have to place a spacer, how much is the space between the glass, and we normally recommend 20 mm is the space between the two glasses. Okay, the key thing is, so ideally if the glass sizes are same, we don't have a differences, but when you have a glass size, different glass size put in the same stillage, it will require more separation. It doesn't fall only in the standards, because when you put more glasses, the first glass tend to stop lay on the next glass. So, we need to have more separators, ensure that there is no physical contact between glasses, there is a uniform gap between glasses at the area, and this does not have an additional stress induced into the next glass. So, the care should be taken in terms of asymmetrical loading. Symmetrical loading is far easier than asymmetrical loading, but nevertheless this facade market does not always have a symmetrical loading. So, in case of asymmetrical loading, the care should be taken to have the spaces possible. So, the spaces are specifically designed for it. There are numerous types of material. These spaces are designed to have whatever the size difference also. It can accommodate the asymmetrical loading. So, now I am coming to the key part, it is the calibration of furnace. The heat soak system, basically the glass, when you calibrate, it is not only the oven. When we calibrate, it is three things which we calibrate: the oven, the glass separation and the separators, all included we will calibrate it. So this is for a complete system, the calibration for a complete system. So how do we do it? For example, if we have a 5-ton oven, normally we do for 100% loading and a 10% loading. So we load the glass with 100% of glass, 100% fully loaded and 10%. So to operate, normal operation will be around 40 to 50% of loading. So we do at extremes, and we will have 20 thermocouples put on the glass at specific locations, and the thermocouples are pre-calibrated. The thermocouples are calibrated in such a way that it does not have a differences of temperature. So it also has which position which thermocouple is doing, and it will be monitored very closely with the systems which is having capability to it. It is done with the third party normally. There are people from Hong Kong who do it, the people from TUV they can do it. So you can see three in this graph, you can see 1, 2, 3. So 1 is first glass reaching the temperature, 2 is the last glass reaching the temperature, 3 is the glass which is reaching the temperature but should be maintained in such a way that it does not cross 320 degrees Celsius. So all 3 is important. One is there can be a first glass which can reach the temperature at T1, okay, the last glass represents at T2, and between this point there are glasses which can go beyond 320. We should have an oven in such a manner that it can control that the this temperature does not go beyond 3. Okay, so this graph is basically to explain it. This is how the typical process happens. So you can see there are thermocouples laid at different locations. There are here 4 thermocouples, like that there are backside there are 4 thermocouples, and inside the glass there are, so 20 thermocouples will be there. So these thermocouple has to be calibrated before we are putting into the operation. So all thermocouples has to be connected in a proper way. It should not have any bends and other things, so that it can add an value into it. So it has to be properly connected. So in a typical process, you can see there will be 20 thermocouples plus 21 is the air temperature. We also measure the air temperature inside the furnace. So there will be 21 thermocouples which is measuring. So this is a start of class. You can see all thermocouples are 35 degrees Celsius, which is typical Indian temperature. This is close to the end of the process where it is around 260 degrees Celsius, and the air temperature is also measured in all these cases. So we wait until all the thermocouples reach to 220 normals. We get a graph close to this. So here if you see, this is the area which is heating zone. So if you have to mention the time, it is roughly 3 hours from here. So 3 hours is taken for the heating, and then the holding is done for 2 hours. After it has been cooled for almost 2 hours. This is a typical real calibration done on one of the furnaces which we have. So key, what is the outcomes you are looking on the capability of oven. We are trying to understand the capability of oven, whether we are able to control the heating rate to less than 3 degrees Celsius is the first thing which we are doing in the calibration. Is the glass free enough and evenly separated and supported? The glass would be free enough, it has to be evenly supported and separated to allow the air to go through this. And the heating time required for this, what we determine in the end of this is, for 100% and 10%, what is the heating time required for this? This is the operating time which we have to use until the next calibration is done. So normally it is done every year. So between one calibration to other calibration, the time taken to do the 100% and 10% loading is average time is used for using as a heating time, and thermocouple positions and trends which we understand from it. So now we are going to the last part of the session, where the heat soak. How do we identify the glasses are heat soaked? We say we put it in the oven, we take it out, and there are specific methods by which we can identify it. So for example, in the top you can see a blue marking. So this marking is done with a specific pen. This is a heat soak oven marker pen. So before putting in the furnace, we have to mark it. It is a UV pen where we can mark a glass with a blue color, and when it comes out of the furnace, it comes in the grey color. Normally it is done at the thickness of the glass, so that it does not have any disturbance to the product quality. And when you see a glass which is heat soaked, will have this, generally will have this mark, which means that it has gone through this oven. If it is not completed the cycle, this will remain as blue. So we want this as to turn from blue to white, and this is permanently fused in the glass. It cannot be taken away by grinding or roughing off. So now we understood what is heat soak and how it is used and how it is calibrated. There are different patterns of glass. So I summarize it what we have learned. So there can these kind of breakages is normally thermal breakage. So when you see a breakage in the glass, it doesn't mean that it is always because of nickel sulfate or because of any inclusions in the glass. We need to understand and observe closely the breakage pattern. Based on that, we can come to a closest conclusion. For example, first breakage represents a thermal instability breakage. Here the compression is not done properly. The second is, and the reason could be overstressing of glass as a tension. For example, you can see a hard body impact with a hammer, with a stone, everything can create an impact. The breakage is typically like this. Third, it could be soft body which is spherical. It can be a small ball which has an impact. The breakage pattern looks similar to nickel sulfate, but there is no butterfly. If there is some hot spot like a stone during installation or a metal frame which is touching the glass, which will have a breakage like this. And in case of nickel sulfate breakages or inclusive breakages, solid inclusive breakages, it will have a breakage which is having a air lobe or a butterfly pattern. So we are coming to the end of this session. So now couple of things I summarize it before I close. One is, not all breaks post installation is because of only inclusions. Second thing is, the heat soaking is a destructive process which eliminates 99% of nickel sulfate breakages during production stage itself. EN 14179 is a standard which is specifying the heat soaking, and it is very detailed, and well calibrated and operated oven is the key to success of this process. Now the standard has been updated. The temperature range has been changed from 280 plus minus 10 degrees to 260 plus minus 10 degrees. This is done on 2016. This is based on several research work which is happening behind it to understand how the heat soaking can be made more effective. At least there are 100 to 150 journals which has been published, articles published on this heat soaking. So this helps us to understand more on heat soaking. Thank you.